Hi everybody. Today we're going to take a look at our Unit 0 Day 3 lesson on solving one-step and two-step equations. Take a moment to pause your screen and try this short warm-up. Describe the order of the steps you would follow to evaluate the expression. Alright, so remember when you are evaluating expressions, we follow the same order around the world. We start with parentheses, then we do exponents, then we multiply and divide. Remember, that's one step, and you go left to right. And then finally, we add and subtract, left to right. So as we look at this problem, we look for the parentheses first. And there is something we can do in the parentheses, but there's actually two things to do in the parentheses. So we still follow PEMDAS within the parentheses. So if we're deciding between subtraction or division, we see that subtraction is in the last step. Division would be in the step in front of it. So we want to go ahead and divide first, in which case we'd get 4 minus 3, since 9 divided by 3 is 3, in the parentheses. Everything else stays the same. Then we finish off the parentheses by subtracting 4 minus 3, and that'll leave us with 5 squared plus 2 times 1. That's the parentheses step. Next, we look for any exponents, and we see that there are exponents at the beginning, or there at least is one set of exponents, 5 squared. Remember, that's not 5 times 2. It means that we're multiplying the 5 by itself. So 5 times 5 is 25, plus 2 times 1. Exponent step is complete. Next, we look for any multiplications or divisions, and we read it from left to right. There is a multiplication at the end, 2 times 1, which is just 2. That leaves us with 25 plus 2, which is 27. So the order that we followed was inside the parentheses. We did division first, then subtraction, because those were in the parentheses. Next, we did the exponent, then the multiplication, and last, the addition. Today, what I'd like to do is do a quick review of Cornell notes with you, because all of the notes that we take in class will have the Cornell note format on your screen. In the top of your note sheet, we want to begin by making sure that we label our notes with our name, the class and or period time that you meet, and the date. For example, you would put your name, the class, Algebra 2, and you could put whether it's period 3, period 5, period 6, or period 7, and then the date. Then also at the top of your paper, in the top margin, you should write the topic for today, which is solving one- and two-step equations, and also the essential question: how do I solve one- and two-step equations? You can pause the screen if you need additional time to set up your notes. And you can do this on your own sheet of notebook paper by drawing lines. Next, I want to point out that we can take our main section of notes, so the lower part of your paper, and split it into 1/3 on the left and about 2/3 on the right. On the left-hand side of your screen, you'll have questions, hints, and main points, main ideas. On the right-hand side is where we put most of our notes. Then at the very bottom, at the end of your notes, when you're all done, you can draw another line across your paper, and below that line goes your summary. Now, if you're not sure what to summarize or how to summarize, think of it as answering the essential question from up above. How do I solve one- and two-step equations? We'll do this at the end of today's lesson. To start with, I'd like to do a think and share. So on your own, if you're watching this video, I'd like you to think about inverse operations. What are inverse operations? So if you didn't get enough time, go ahead and pause before you listen to the next part. What are inverse operations? Well, inverses sometimes are called opposite operations, Okay, operations that undo each other, like addition and subtraction, or multiplication and division. So if you think about it, let's take a number like 10. If I add 3, how would I undo adding 3? I would subtract 3. 10 plus 3 is 13, and 13 minus 3 is 10. So whatever operation you do to the 10, you can undo that with an inverse. If I divide it by 2 and then multiply it by 2, I'll still get 10. 10 divided by 2 is 5. 5 times 2 is 10. So multiplication and division will also undo each other. In a two-step equation, which operation do you undo first? So a two-step equation might look like this. 2x minus 5 equals 7. And in that equation, there are two different operations to undo. There's the multiplication between the 2 and the x, and there's the subtraction. So when we are trying to decide which one to undo first, we actually follow SADMAP, which is PEMDAS written backwards. So we start with undoing any addition or subtractions. Remember, that's the same step. Then we undo any divisions or multiplications. Again, that's the same step, the second step. Then we undo any exponents. And last should be whatever's inside the parentheses. So let's look at some examples. Here's an equation, x plus 8 equals 19. When you're solving an equation like this, it can be helpful to draw a line, or what I call train tracks, around the equal sign. This gives you a visual representation of the two sides of an equation, which represent a balance. Identify where the variable is in relationship to the train tracks. In this case, the variable is on the left-hand side, x plus 8. Our goal is to try to get x completely by itself. So we have to get rid of the plus 8 in this problem. So think about what is the inverse of adding 8, or how do we undo adding 8? Well, we would take away or subtract 8. Now, the fundamental rule of algebra says I have to do the same thing to both sides of the equation to keep it balanced. So I subtract 8 on each side, and if I take the positive 8 and subtract 8, it gives me 0. X plus 8 minus 8 is just x. On the other side, 19 subtract 8 is 11. So x equals 11 is my solution. Now we can always check this by substituting in the value of the variable to our equation. We started with x plus 8 equals 19. Let's replace the x with the number 11 and check to see if that's true. Is 11 plus 8 equal to 19? Well, yeah, 11 plus 8 is 19, and 19 equals 19. Just confirms that x equals 11 is our solution. So in this example, there was really only one thing to do. We had to subtract 8 from both sides. That makes it a one-step equation. In our second problem today, 4a plus 3 equals 11, I see that there are two operations. There's the multiplication between 4 and a. Remember, that's 4 times a. And there's also the addition, the plus 3. So think about following the reverse order of operations, which we can remember using SADMAP to help us with the order of how to solve. We want to start by undoing any subtractions or additions. Well, I see that there's a plus 3 in this problem, so let's start by taking away 3 to undo it. 3 minus 3 is 0. But I still have that 4a on the left-hand side. And 11 minus 3 is 8. Now we have to get rid of the multiplication, so we divide to undo multiplication. Divide by 4 on each side, and our final answer, when we take 4 divided by 4 to get 1, or 1a, and on the right-hand side, 8 divided by 4 is 2. A equals 2. We can always mentally check our answer if I replace the a with the number 2, I should get 11 based on my equation. So 4 times 2 is 8, and 8 plus 3 is 11. Our answer checks out. In our third example, we have 8 equals 3r minus 1. You might notice this time that the variable is on the right-hand side, and that's okay. We still solve the problem the same way. We still use inverse operations, and we work backwards using SADMAP. So we start by looking for any additions or subtractions that we can undo. And I see that we can undo the minus 1 as long as we add 1 on both sides. Well, 8 plus 1 is 9. The negative 1 plus 1 is 0. And I still have the 3r. Remember that 3r is the same as 3 times r. So we want to undo multiplication by dividing. 3 divided by 3 is 1. 9 divided by 3 is 3. R equals 3 is our solution. Then again, you can always check your answer by plugging in 3 in the place of r in the equation. 3 times 3 is 9, and 9 minus 1 is 8. In our fourth example, we have 9 minus c equals negative 13. I start by drawing my train tracks. I notice that the variable I'm trying to solve for is on the left-hand side, in which case I want to try to get rid of the 9 first. Now this problem can be a little tricky because the temptation might be to see the subtraction and want to add 9 to both sides, like this. However, when you do that, what's 9 plus 9? Well, that's 18, which if we do this, it's going to give us 18 minus c equals negative 4, and that doesn't help us try to get c by itself at all. So think of it more as what can I do to that 9, which was a positive 9, to make it go away, to make it turn into a 0. So we actually have to take away 9 on a problem like this to get the 9 to cancel out. 9 minus 9 is 0, but be careful, what's left over is negative c equals negative 22. Then we have to remember that when a negative sign is in front of a variable, that's the same as saying negative 1 times that variable. So if we want to undo negative 1 times c, we're going to divide by negative 1 on both sides. A negative divided by negative is a positive, so that's going to leave us with positive c. And on the other side, again, a negative divided by a negative is a positive. That leaves us with positive 22 as our solution. If you check your answer, put 22 in the place of c. 9 minus 22 equals negative 13. That is true. So 22 is our correct answer. I'd like you to pause the video and try number 5 on your own. All right, let's check and see how we did. Remembering to follow SADMAP when solving equations, we want to start by looking for any subtractions or additions that can be undone. We see that there's a plus 4 in this equation, so let's start by subtracting 4 on each side. 4 minus 4 is 0, so that's going to leave us with x over 6 equals 15 minus 4, which is 11. Now it may look like it's a fraction, and you might be wondering, well, how do I get rid of a fraction? But remember that the fraction is really just a division. So if I want to undo divided by 6, I can actually multiply by 6 on both sides. And on the left-hand side, we take 6 times x over 6. It's going to look like this, which we know is just x. And then 11 times 6 is 66. X equals 66 is our solution. If we plug that in to check, 66 divided by 6 is 11, and 11 plus 4 is 15. So 66 is the correct answer. What I'd like you to do is take a few minutes, and you can pause your screen when you're ready, to write 2 or 3 sentences at the bottom of your notes to summarize your learning for today. I would encourage you to answer your essential question. How do I solve 1 and 2 step equations? It might be a good idea to include the vocabulary that we use today, including inverse operations, and also to include the concept of using SADMAP when we solve equations. Your assignment today is posted in Schoology. It's Unit 0, Day 3. I'd like you to practice by using Kami. So you want to go to your Schoology course, and after you've found your course, click on the assignment in the upcoming section. If it's not there, you can scroll down to the Unit 0 Algebra Review folder and click on it inside the folder. So inside the assignment, it says click on the assignment below using the Kami option. So down below, you'll find the gray button with the blue K in it. That's how we open assignments using the Kami app. It then says to use the Kami draw tools to show your work and solve each equation. Make sure you click the Turn In button to submit your work to Schoology. This takes about 3 clicks. And the effort rubric, scoring rubric, is here for you to view as well. So we click Open Assignment with Kami. If you've never done this before, you might actually have to click Allow to sync your Google Drive or Google account with Kami and Schoology. It may take multiple clicks. You'll notice I already have something drawn on here, and that's because Kami saves your work automatically. So I'm going to go ahead and erase that. On the left-hand side is your toolbar. Normally, the Select tool is what is selected when you begin. If you go down to the 3rd section of tools, we have Drawing, Shapes, and Eraser. If I click Drawing, you'll see a stroke thickness is currently set to 1, but if you want to draw thicker strokes, you can go ahead and change, and it gives you a preview of what that looks like. I like just using 1 for regular writing. If you hover over any of the color options, you can get additional colors. If you want even more than that, choose the More Colors option. Click which color you want to change, and then choose a different color. And hit Save. Now when you hover over the 3 colors, you'll get to see the 9 colors that you can edit. Now you're able to draw whatever you want. Let's say you drew something like this and you really didn't want that. You can click Undo at the top of your screen to undo 1 stroke at a time, or the shortcut is Control-Z on your keyboard, or the Eraser tool. Now on most tools, when you erase, you'd have to erase all the way along there. In Kami, if you want to erase something and it was all 1 pen stroke, all you have to do is click and swipe. Or if you're using your screen, just swipe across and the entire pen stroke goes away. It can be a very useful tool. So after you complete your work, and I should mention, I would like you to zoom in using either the zoom features, or you can scroll or zoom in or out on the trackpad just like you would on a mobile phone, and it will zoom in. I would encourage you to zoom in as far as you can. Try to get the problem centered in your screen, because after you write it out, we'll do this first one, I guess, with you guys, at least part of it. We add 17 to undo subtraction. We get x equals, and you know what? I'm going to make you do that last part. But I want you to see that up close, it looks like that. When I zoom back out to 100%, take a look. It looks pretty nice and neat. So I encourage you to zoom in on a problem, and then you can just scroll over to get to the other problems. You don't have to zoom out, zoom in, zoom out, zoom in. It just makes it a lot easier when I go to look at your assignment after you're finished. All right, so when you are done, I would encourage you to zoom out, double check that you've done all of the problems. Sometimes there's a second page. On this one, there's just one page. Then in the upper right-hand corner of the blue toolbar, it says Turn In with a save icon. Now it automatically saves and updates just like a Google document would. But if you click Turn In, you'll have to click Turn In again on the blue button. And what it's doing is it's saving and adding to your Google Drive, but it's also going to take you back to Schoology. So I can't do it because I'm logged in as a teacher. I don't have the ability to turn in assignments. It hasn't been assigned to me. But when you do, it'll bring you back to Schoology and it'll say, would you like to submit the assignment Unit 0, Day 3 with your file name? You have to hit Submit, and then it submits to your teacher. If you have any questions or if you're having any problems with Kami, please let me know.